Hello. In this video, I'm going to go through some of the ideas of algebraic proof and making sure that you're able to use algebraic proof in two of the most common types of GCSE questions that have existed on this idea. So before we go too far into this, it's important to realize what a proof is. In maths, a proof is a sequence of correct logical steps that demonstrates the statement is true. So you want to show mathematically that something is true, and you want to make sure that each stage that you're using in your working makes sense, is clearly explained, and would get you to the point of showing that something definitely happens. A proof by contradiction, which is another way you can prove things, is where you can find one instance where a statement is false. So for example, if someone said all prime numbers are odd, you could prove by contradiction that that's not true, and you could find that one example of a prime number that's not odd in order to show that that statement at the start was false. And so the main type of proof this video is going to focus on is the first one, about how we show things are true in a series of logical steps. So I'm now going to go on to an exam question on this. So here we have a question where we're asked to prove that a certain algebraic expression is a multiple of 4 for all positive integer values of n. And so putting everything to one side for the moment, the only thing we can really do with this algebraic expression is to try and simplify it. And then at some point towards the end, try and show that what we have is a multiple of 4. So we're going to start off by expanding and simplifying these brackets. Now that's going to take a little bit of time, but if we expand the two squared brackets separately, we'd end up at this point. And if we take care enough when we are subtracting the second set of squared brackets, once they're expanded, we would then end up with a lot of sign changes, a number of terms cancelling, leaving us with just 12n at the end. Now, how are we going to show that that's a multiple of 4? Well, 12n is 4 lots of 3n. And since we can show that 12n is a multiple of 4, because all multiples of 12 are multiples of 4, then we have shown that this entire algebraic statement or expression at the start basically boils down to something that is a multiple of 4. And we want to make sure that we include a statement like this towards the end. Now the proof has been all those mathematical stages that got us there, from expanding brackets correctly, cancelling terms correctly, and then getting to a point where we're able to demonstrate that our final term or terms is indeed a multiple of 4. So although what I get is 12n, I'm showing it's a multiple of 4 by considering what that means at the end. So this second question that I'm going to go through is about proving using algebra that the sum of two consecutive whole numbers is always an odd number. So to start off with, you want to be able to consider, well, how do we show any whole number to start off with? Well, we want to use the letter n. That's a general letter that we'd use in proof to show any whole number or any integer. From here, we would then say, well, what would be the next number after that? Well, that would be n plus 1. Consecutive meaning the next one, or the one that's immediately after it. So if n was 5, our next consecutive number would be 6. Well, that's 5 plus 1, so that's why we get n plus 1. Now when we look at the sum of these two, we're going to get 2n plus 1. And what we want to do now is start showing that 2n plus 1 is odd. Well, the 2n part is a multiple of 2, so this will always be even. Any number multiplied by 2 is even, so that bit is fine. But then because we're adding 1, that means it must make it an odd number. Any even number plus 1 is odd. And so we have then proven what it was that we were expected to prove. Now in other questions, you may have to prove something different to do with odds and evens or consecutive numbers or any numbers. But you want to be using something like 2n for your even numbers and then 2n plus 1 for odd. And if you do that and follow the stages of the problem that you're expected to do, whether it's squaring or multiplying, you should then be able to demonstrate what it is that you're expected to show at the end. Hopefully this has been a quick video about proof, and that it will help you to go on and solve many other problems about proving various things using algebra. Thank you.